Hello there and welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at polynomial long division. By the end of this lesson, you should understand the division algorithm to be able to perform polynomial long division step by step. To be able to handle missing terms by using 0 as placeholder, then express the results as quotient plus remainder over divisor. After all this, you should also be able to use multiplication to verify your answer. On our right hand side here, we have some terms we'll be looking at, and which you'll be hearing me use them as the lesson proceeds. The first one is the dividend. When we talk of dividend, it is simply the polynomial being divided. You see, so if I have a over b, for instance, or a divided by b, this is the polynomial being divided, hence we call it the dividend. So for this example we have over here, which says x cubed plus 2x minus 5 divided by x minus 1. This is what we are dividing. You see, so that becomes our dividend. Then what we are dividing by, so if we have a over b, we are dividing this by this. So the denominator becomes your divisor. So for instance, if you have this same example, x cubed plus 2x minus 5 divided by, this is our divisor. Now, after you divide, the whole number you get, we call it the quotient. So whatever you get after division, if you have a divided by b, and then your answer becomes a c, then remainder d. This particular one, this particular whole number is what we call the quotient of your division. Then the remainder is obviously the remainder. In our next slide, we'll be looking at the division algorithm. And then talking of placeholder zeros. You know, for polynomials, if you have to write them in the standard form, the first term should always be the one with the highest power. So if we have, let's say, x raised to the power 3 plus, or let's use minus 5, you realize that there is no term in terms of x squared, and neither is there a term in x. So to help you do your polynomial division, you'd have to represent all those with 0 coefficients. What we mean is, instead of x cubed minus 5, we can rewrite it as x cubed. Then how many x squared do we have there? We have a 0x squared. How many x's do we have there? We have a 0x. And then we come to our minus 5. So we call these the placeholders. They are of no value, but they are holding the place of those degrees so that it can help us do our division properly. These are the terms you'll hear me use as the lesson proceeds. Without much ado, let's quickly go into the lesson. Talking of the division algorithm. If you have a divided by b, now if we divide this using our long division, we always put our b out here and then the a in there. Now you divide whatever you want to divide, and then you'd always get your whole number up here. So let's put our whole number here, and after all the processes, we get what we call a remainder. So let's represent that with d. Now in terms of c, b, and then d, we can write our a, and that is to say our a, which is our dividend, is equal to the whole number you have here, which is your quotient. So c, then times the divisor. So let me rather write it as b c, then plus what you have as your remainder, d. Now, if we were to use polynomial functions, then we would say if we have a p of x dividing or divided by your d of x, then in a long division format, we are going to have the same as we have done here. So our p of x remains inside, that is our dividend. Then our divisor remains outside. Then after our division, we'll get our quotient, call it q of x. And then we would finally get a remainder, which we should call r of x. So with that, we can say our polynomial p of x is equal to the quotient times the divisor, that is d of x times q of x, and then plus our remainder we have over here. This is the whole idea of the division algorithm. Now, you can see there are steps that we need to follow when we want to use the division algorithm. I wouldn't just read it out for you. It might not make sense. So the critical warning here says always write the dividend in descending powers of x if a term is missing. What we simply mean there is what we illustrated over here. That is this illustration. So when there are no terms of a particular degree, introduce them with placeholders. You see? So I would actually take an example to illustrate the step-by-step division. So in order to go through the step-by-step long division method, let's use this example. So it says we have to divide 2x cubed, then plus a 3x squared minus a 5x plus 2. Let's divide all of this by an x plus 2. And as you can see here, it says we should express it as q of x plus r all over x plus 2. What this means is, you see, if we divide 3 by 2, we'll have 2 into 3 ones. 2, 1, 2. If we subtract, we have our 1. That simply means for 3 divided by 2, we can rewrite it as what? One whole number. This is our one whole number here. 1 over 2. That is 1.5. You can also rewrite it as 1 plus 1 over 2. You see? So all this is telling us is after our division, let's rewrite it as the sum of the quotient and then the remainder over the divisor. So let's look at the steps involved. So before we start, we have to take heed to this critical warning here. It says always write the dividend in descending powers of x. We have x to the power 3, we have x squared, and then we have to the power 1, and then to the power 0 over here. So they are already in the descending powers of x. So we are good to go. So with that, let's put our divisor in here. So we have x plus 2. Then our dividend is in or under the division sign. That is 2x cubed plus 3x squared, then minus a 5x plus 2. Now, this is the point I advise you really pay attention, because if you are able to get it, there is no polynomial you can't divide. It says we should divide the leading term of the dividend by the leading term of the divisor. This is the leading term of the dividend, and this here is the leading term of the divisor. So what it means is let's divide 2x cubed by x. So the leading term here divided by leading term here. See, if you have to divide, we know this x takes out one of the x's here, so that we have 2x raised to the power 2. This we have over here, we are going to make sure we write it here. So 2x raised to the power 2. Now this gives us the first term of the quotient. You see, so after this successful division, what we want to do is we have to multiply the entire divisor by the term and write it below the dividend. So this that we've gotten, this answer we've gotten, we are come to multiply it by this term of the divisor and also multiply it by this term of the divisor. You remember when we are doing long division, anytime we have our quotient, we multiply and then write something here and subtract. It is the same thing we want to do here. So we have 2x squared times x. That gives us a 2x cubed. That is 2x squared times x. Then we come to 2x squared times 2. That will also give us a 4x squared. You see? So after this, what we do is we subtract to get our remainder. In subtracting, you see, there are no terms over here. What we have here, there are no terms in terms of the x. So you can simply choose to put plus 0x and then plus 0. Or you can just leave it as it is. After which we do our subtraction. We've gone through how to subtract polynomials. You can always refer to that if you have any doubt here. So we have 3x squared minus 4x squared. That is 3 minus 4. That gives us a negative x squared. Then we have 2x cubed minus 2x cubed. What happens? We have a 0x cubed. Or in other words, we just have a 0, so we don't write anything there. So with that, you are done with the first or the highest degree. We are now coming to work on what? X squared. So now that we are done with that, let's bring this new term down here. You see? So bringing this new term down here, we are going to get a minus 5x. And then we can also bring this as well, so that we have what? Plus 2. Just as we do in our normal long division. You finish dividing, the remaining numbers, you bring them down so that they can also come and then divide. We start our whole process again. So it says, divide the leading term of the dividend by the leading term of the divisor. This time around, this becomes our dividend. We are done working on the original dividend we were given. So this new remainder becomes our new dividend. Hence, we have the leading term being a negative x squared, and our leading term here also being an x. If we divide this, we are going to get a negative x. After the division, you now come and then multiply. So we are just repeating the same process over and over. We are coming to multiply this new quotient we have by x and also multiply it by 2. So that we have x times negative x, giving us a negative x squared. Then we have 2 times negative x. That also gives us a negative 2x. Then what do? We subtract. You see how nice and simple it is. So in our subtraction, we have negative 5x minus negative 2x. That simply gives us, let's say, a negative 5x minus negative 2x. These two negatives will give us a positive. So we have negative 5x plus 2x. Evaluating this gives us a negative 3x. So with our negative 3x, we have negative x squared minus x squared. The negative here gives us a positive. So indirectly, the x squared cancels itself. We are done with that. This here is our last term that had no counterpart to do our subtraction. Hence, we would also bring it down. So we have a plus 2. And then we go over the process again. So we have a negative 3x. That is our leading term right here. Let's divide it once again by this leading term. So you realize that it is only the leading term we use to do the division, after which we just multiply by all the terms. Use just the leading term, multiply by all the terms. So negative 3x divided by x simply gives us a negative 3. So we come up here and write our negative 3, after which we do our multiplication. So that is x times negative 3 gives us a negative 3x. Then we have our 2 times negative 3, which also gives us a negative 6. After which we do our subtraction. So 2 minus negative 6. 2 minus negative 6 gives us a 2 plus 6. And that gives us an 8. Negative 3x minus negative 3x then gives us what? A 0. Is there any other number we can bring down? There is no number we can bring down. And our leading term here becomes 8. And the leading term here becomes what? X. X cannot divide 8. Hence, this here becomes our remainder. That is our remainder. You see? So what do we do with this remainder? We can then rewrite our question in this form. So it says quotient. This here becomes our quotient. You see? So our quotient is simply 2x squared. Since it won't go here, let me just write it on the next sheet. So expressing it as qx then plus r over x plus 2, it simply implies we have our quotient, which is what? 2x squared minus x minus 3. This here is our quotient, what you have on top. Then plus our remainder. This is our remainder. So 8 over, then you have your x plus 2. As simple as that. That is our final answer. You see? So once again, the steps involved in dividing is very simple, and then it is repetitive. So just be able to identify your first step. It says divide the leading term. We are always dividing the leading term by the leading term in the dividend. So we work with leading terms only, after which you then multiply. So if you divide by leading term, the multiplication is not only by leading term. All the terms in the divisor will join in the multiplication. After which we do what? We subtract, get our remainder, and start the whole process again. You see, this is, you repeat these steps 1 to 4 until the remainder has a lower degree than the divisor. This is our divisor here. This is our remainder. This was our remainder after the first step. You realize that this remainder has a degree which is higher than the degree we have here. You see, so you'd still divide. This remainder has a degree which is equal to the degree we have here. We'll still divide. Then the last one, this has a degree of what? X raised to the power 0. And it's actually lower than the degree we have here. So we stop. If we stop, that becomes our remainder. So that is what we've been able to achieve over here. If the understanding isn't clear at this point, let's solve some few more examples to enhance your understanding. Okay, so for this second question here, it says x cubed minus 7x plus 6 divided by x minus 2. You take note of something here. Realize that the power of x, or the degree of this function, is to the third, but we don't have x to the power 2. You see, so we'd have to rewrite it in that form so that we can work with it. That is to say, instead of x cubed minus 7x and then plus 6 divided by x minus 2, let's rewrite this particular one as x cubed minus or plus or minus 0x squared and then minus the 7x plus 6 and then divided by the x minus 2. So this is what we have. You've rewritten it so that your powers are in descending order. With this, we can now proceed with our division. So in order to divide, we know what our dividend is and then what our divider or divisor is. Hence, I'm going to put x cubed plus 0x squared and then minus 7x plus 6 right here. And then we have our long division sign. We have our x minus 2. So with that, we can start our division. The same procedure. Divide each term only by the leading term in here. So you have x cubed divided by x. So you can quickly do it here. X cubed divided by x. This one reduces this power by 1. So that you're left with what? X to the power 2. So x cubed divided by x gives us x to the power 2. Then now do our multiplication. X times x to the power 2 gives us x to the power 3. The negative 2 times x squared will give us a negative 2x squared. You see, after which we do our subtraction. So if we subtract, what are we going to get? A 0x squared minus negative 2x squared. So the negative and negative becomes positive. Hence, we are left with a 2x squared. And we know this here cancels out. So with that, we bring the remaining down. So you can choose to write all you have down, or you can bring all of them down. But then I choose to write just one. So with that, let's proceed. So we start again with our leading what term? 2x squared divided by an x. By now, you should be able to do it. So we have a positive 2x. Then x times 2x gives us a 2x squared. Then negative 2 times positive 2x. That gives us a negative 4x. You see, then with that, we come again and then do our subtraction. This is the same thing we keep doing over and over again. Negative 7x minus negative 4x. It becomes a negative 7x plus the 4x, which gives us a negative 3x. So with the negative 3x, we know these ones now would go off. So our last term that has not been touched will now come down. So that we have what? Our positive 6 right here. So with that, we have negative 3x divided by x. That gives us a negative 3. So x times negative 3 will give us a negative 3x. Then you have your negative 2 times negative 3. That also gives you a positive 6. Then we do our subtraction again.
So that we have our 6 minus 6, which gives us a 0. Then negative 3x minus negative 3x will also give us a 0. Hence, we have nothing left. So it simply means that the division we have done, that is x cubed minus 7x plus 6 divided by the x minus 2 is equal to the answer. This is our quotient. So it is equal to x squared plus 2x minus 3. As simple as that. So this is how we actually divide polynomials using the long division method. So for all that we've done, you realize that the coefficients of the divisors are all 1. You see, let's look at how it is going to be if the coefficient of our divisor is not 1, but then you have a number there. So we have our third question here, which says 6x cubed plus 7x squared minus 5x plus 2. And that is being divided by a 2x minus 1. You see. So with this, you realize that the powers are already in their right form, in descending order. Hence, we wouldn't have to change anything. We can quickly go straight forward and then put our 2x minus 1 right here. And then our division sign is going to be here. Then we have what we have inside here, which is a 6x cubed plus a 7x squared minus a 5x plus a 2. So we do our division one after the other, just as we have done. So 6x cubed divided by 2x. 6x cubed divided by a 2x. 2 divides itself once and then into 6 thrice. This x reduces this by 1. Hence we have x squared. So 6x cubed divided by 2x gives us a 3x squared. After which we now multiply by each of these terms here. So 2x times 3x squared gives us a 6x cubed. The negative 1 times 3x squared gives us a negative 3x squared. Then we do our subtraction. So with our subtraction, we know we would have to bring this line. Then we say 7 minus a negative 3. 7 minus negative 3 becomes a 7 plus 3. And 7 plus 3 gives us a 10. So we have 10x squared. And as usual, this goes off. So 6 3 cube minus 6 3 cube goes off. So we bring this down, and then this as well comes down. So then we have 10x squared, then minus 5x. You can also write the plus 2. It doesn't change anything. We start our whole process again. 10x squared divided by 2x. That is the 10x squared here divided by the leading term we have here. The 2 divides 10 to give us 5, and then this x reduces this by 1. Hence, we have our x over here. So that gives us a positive 5x. Then we do our multiplication. 5x times 2x gives us a 10x squared. And then 5x times negative 1 also gives us a negative 5x. We then do our subtraction. So we have a negative 5x minus 5x. Because of the 2 negatives we have over here, it's going to turn to a positive. Hence, we have negative 5x plus 5x. That gives us what? Nothing. So it goes off. Then we have 10x squared minus 10x squared. That also gives us nothing. Hence, what we are left with is just the 2. Now, the criteria to stop your division says we should repeat step 1 to 4 until the remainder has a lower degree than the divisor. So looking at what we have here, the degree of x here is 0. and it is lower than what we have here as 1. Hence, we'll need to stop. We can't continue with our division any longer. Hence, it simply implies that our 6x cubed plus 7x squared minus 5x plus 2 divided by 2x minus 1 is giving us, this is our quotient. So we have a 3x squared plus 5x, then plus the remainder, which is 2 all over what? 2x minus 1. So the quotient plus the remainder over the divisor. As simple as that. So you realize that whether the coefficient of our divisor is not 1 or it is 1, you still use the same procedure and you get your right answer. Now, in view of that, we would answer our last question for this session, and it involves both our long division and then a proof that is showing that the division algorithm is true. As you can see, it says show that x to the fourth minus 3x cubed plus 2x squared minus 5x plus 4 all over x squared plus x minus 2 is equal to x squared minus 4x plus x plus negative 21x plus 20 all over x squared plus x minus 2. If you're able to do that, we then verify that p of x is equal to what? The divisor times the quotient plus the remainder. So let's do the first one, which says we should show our long division. So with a long division, as you can already see, the powers are in decreasing order. So we have 4, 3, 2, 1, and then the last one, which is our constant. Hence, let's put our divisor out here, which is the x squared plus x minus 2. That is from this, the divisor. Then we have, for the dividend, we have x to the fourth minus 3x cubed, then plus a 2x squared minus 5x, and then plus 4. So with that, let's start our division. This time around, we are going to be more direct because we've done so many, and then I'm sure you have come to an understanding of how to go over each and every one. X to the power 4 divided by x squared gives us an x squared. So we have x squared, then x squared times x squared gives us x to the power 4. Then we have x times x squared, that gives us a positive x to the power 3. Then negative 2 times x squared gives us a negative 2x squared. After which we do our subtraction. So the subtraction, you have 2x squared minus negative 2x squared. That gives us a 2 minus 2 plus 2, which is a 4. So we have our 4x squared, then negative 3x cubed minus x cubed. That gives us a negative 4x cubed. So we needed to write our positive here, and this gave us a negative 4x cubed. So as usual, this goes off because they cancel each other. Our remaining terms can then be brought down so that we have a negative 5x and then plus 4. We start all over again. Negative 4x cubed divided by x squared is going to give us a negative 4x. So negative 4x times x squared gives us a negative 4x cubed. Then x times negative 4x gives us a negative 4x squared. Then we have our negative 2 times negative 4x. That gives us a positive 8x, after which we do our subtraction. Negative 5 minus 8, that becomes a negative 13, so negative 13x. Then for the 4x squared minus negative 4x squared, it becomes a 4x squared plus 4x squared, which then gives us a positive 8x squared. Negative 4x cubed minus negative 4x cubed go out, right? They are cancelled. Hence, we can bring our 4 down here. That is from this stage. Then we start the whole process again. 8x squared divided by x squared would give us a positive 8. So the positive 8 times x squared gives us 8x squared. Then x times 8 gives us a positive 8x. And then our negative 2 times 8 gives us a negative 16. We do our subtraction. We have 4 minus negative 16. That becomes a 4 plus 16, which is a 20. A positive one, of course. Then negative 13x minus 8x would give us a negative 21x. And as usual, this is cleared off. What do we have now? There is no way we can continue because looking at the degree of our remainder, it is less than the degree of our divisor. And the rule says anytime we reach that point, we end the division. Hence, we have been able to show, you see, so we can say, hence, we've been able to show that what our x, which is to the fourth, minus 3x cubed plus 2x squared minus 5x plus 4 all over the x squared plus x minus 2 is equal to, remember, this is our quotient. So we are using the quotient, then plus the remainder over the divisor. You see, we are using this. So our quotient was what? X squared minus 4x plus 8. And then plus our remainder, which is now what we have over here. So negative 21x plus 20 all over this, which was the divisor right here. So we have x squared plus x minus 2. That is all. You see, so it was very easy to prove. All we needed to do was to divide and then write it in this form. Now, when it comes to what we've been asked to prove, that is to say p of x, the polynomial is equal to the divisor, then times our quotient, and then plus our remainder. Let's see how that goes. So first of all, the polynomial, which is p of x, is the x to the power 4 minus 3x cubed plus 2x squared minus 5x, then plus 4. This was what the polynomial was. So if you want, and looking at what we were able to do, the divisor, which was d of x, is equal to what we used to divide. That was the x squared plus x minus 2. And our quotient after the division was what? X squared minus 4x plus 8. And then the remainder was what? Negative 21x plus 20. So we'll need to solve this and then prove that it gives us our r of x. So first of all, let's try the d of x times k of x. So our d of x was x squared plus x minus 2. And we want to multiply it by the k of x, which is x squared minus 4x plus 8. Using our distributive law we have considered in our previous lesson, x squared multiplies everything we have in the bracket. So does x, and then so does the negative 2 as well. So let's start with the x squared. X squared is going to multiply the x squared minus 4x plus 8. And then the positive x is also going to multiply x squared minus 4x plus 8. And then our negative 2 also does same. So multiplying, we have x squared times x squared, which gives us x to the power 4. X squared times negative 4x, that gives us a 4x to the power 3. X squared times 8 gives us an 8x squared. X times x squared, we have x to the power 3. X times negative 4x, we have negative 4x squared. X times 8, we have an 8x. Negative 2 times x squared, we have negative 2x squared. Then negative 2 times negative 4x, we have a positive 8x. Then negative 2 times 8 gives us a negative 16. We can then group like terms and simplify. For the x to the power 4, it is the only term with a degree of 4. But then for that of cube, we have this right here, which is a cube. We have this as well right here, which is also a cube. Is there any other cube? No. Then we come to that of the squares. So for the squares, we have this term, which is a square. And then we have this term as well, which is a square. And finally, we have this as well, which is also a square. So working on the cubes, we have negative 4 plus 1. That gives us a negative 3x cubed. Then working on the squares, we have 8 minus 4, which gives us a 4. Then minus 2, that gives us a 2. So we have plus 2x squared. Then for those of just the x, we have 8x plus 8x. That gives us a 16x. Then for the constant, minus 6. Now this we have here is the dx, d of x times k of x. That is to say, the divisor times the quotient. But what were we asked to prove? We're asked to prove that p of x is equal to the divisor times the quotient, then plus our remainder. And remember, our remainder was this we have here. So we have our d of x times k of x, which is x to the 4th minus 3x cubed plus 2x squared plus 16x minus 16. Then plus our r of x. So for the r of x, all it has is negative 21x. So I'm coming to put that negative 21x right here. And then plus 20. It has a 0x squared. And it also has a 0x cubed. And it also has a 0x to the power 4. So this is what we have. Now let's add. Negative 16 plus 20 gives us a 4. So we have our 4. Then 16 minus 21x, 16x minus 21x. That gives us a negative 5x. What we have here, 2x plus 0x squared, still maintains the 2x squared. Then negative 3x plus 0x cubed. We have negative 3x cubed. Then finally, x squared plus 0x squared gives us x to the power 4. This is what we have left. Comparing it to our p of x, are they the same? They are the same. We have x to the power 4, this x to the power 4. Negative 3x to the power 3, this is negative 3x to the power 3. 2x squared, this is our 2x squared. Negative 5x, this is our negative 5x, and then the 4 also follows. So that is to tell us that p of x is really equal to what? D of x times q of x plus r of x. This brings us to the end of this lesson. I do hope it was helpful. If there's any issue of concern, you can always let me know in the comment section, and when I'm notified, I'll address that for you. As usual, I'll leave with some exercises so you try on your own just to test your understanding. So here we have some 6 questions you can try on your own just to test your understanding. These are all based on what we have done already. I do hope you'll be able to do it. Now, in our next lesson, we'll be looking at what we call the remainder theorem. If you look at this example we solved here, that is, for this particular example, there was no remainder, and the remainder was equal to 0. It gives rise to a new theorem we call the remainder theorem, and then the factor theorem. If you want to know much more about this, you can visit the playlist and then look at the next lesson where we talk about the remainder and the factor theorem. I do hope this lesson was helpful. If there's any issue of concern, you can always let me know at the comment section. When I'm notified, I would address that for you. If this is your first time on this channel, you think it will be of help to you, you can also choose to subscribe if you so do wish, so that anytime I release a video, you'll be notified as well. See you in our next lesson, and bye for now. Do stay safe.